I'm all the way from the northeast of England, quite a distance away. We've got a good few people from there. So, for example, years ago, we had Lord Armstrong, famous engineer, actually lived in a house built on his land. We also had George Stephenson, did the trains. Fast forward a little bit, and because we're a canny bunch in the northeast, we know people by their first name. We've got Ant and Dec in entertainment, Cheryl singing, I think, so you can correct us. And now we've got Colin. Colin's from Scott Logic, which is a technology and service company. So we've gone from the industrial revolution northeast to a bit of light entertainment. And now the northeast is really a hotbed of technology. AI is now the new revolution. So over to Colin for his slant on what AI is.
Yeah, thank you very much. Cheers for that. You've already got me onto digression there. Ant and Dec. I was in the airport once at Newcastle, and I went to the toilet. Don't worry, this is a clean story. And there was one of Ant and Dec in the toilet, and I messaged my wife and said, "There's one of Ant and Dec. I'm not entirely sure which one it is." And she said, "How big is his forehead?" And then, anyway, but yeah, I was on the same plane as one of Ant and Dec. So I'm Colin Eberhardt. I'm the CTO of Scott Logic. We're a UK-based software consultancy, founded in the Northeast. We're now in various different locations. We generally build complex things for our financial services clients, and that's pretty much what I'm going to say about that. My talk has got a little bit of a crossover with some of the things you heard Adrian mention this morning, but I'm going to add a healthy dose of reality to spice things up a little bit. So my talk is a little bit of a roller coaster. It reflects my own feelings about AI as a technology. Some days I think it's amazing, others I think it's, you know, the end of the world or whatever, or just hype. So I'm going to take you on a little bit of a roller coaster journey with this talk. So we're going to start with the more exciting hype side of things. I want to reflect on this question: what has made generative AI such a disruptive technology? And you've probably heard of lots and lots of different applications of generative AI, but I just want to boil it down to just a few simple points that I think are what has really made this technology something else. So the first is, we've now seen general purpose AI models. Prior to generative AI and large language models, AI has been around for years, but generally, if you want to do things like translation, if you want to do semantics, if you want to do sentiment analysis, previously you'd have to take a specialized model, you'd have to train it with a specialized data set, and then run it to perform exactly that task. You don't have to do that anymore. These large language models are highly versatile and can perform a whole number of different tasks using exactly the same model, which is a huge leap forwards in our AI capability. The next is the human language APIs. Again, taking a step back just a few years, if you wanted to run an AI model, you'd either have to be a Python developer or befriend a Python developer, and generally they're a nice bunch. But now, we can all use these AI models because if you want it to do something, you simply ask using human language. And it's the combination of these 2 points are what I think has caused such a significant leap forward in AI in the past couple of years. But there's a little bit more. The first is the reasoning capabilities. Now, this is something that wasn't immediately apparent when the large language models were first launched approximately 2 years ago. But what people have been discovering is if you prompt them, if you ask them to solve problems in certain ways, they are starting to demonstrate a level of reasoning. What this means is that there are models that have been used to tackle various exams. By prompting them in certain ways to think about the problem, their capabilities are enhanced. And the next point, use of tools. You're probably aware that there are some certain limitations with large language models. There's a cutoff date in their training data set. More recently, people have worked out how to connect these models to search engines, to corporate data sets, to all kinds of other things, to calculators. Large language models are not terribly good at maths. Connect them to a calculator and they're as good as you or I at maths. Interestingly, the way I look at this, reasoning and the use of tools, taking a step back, this is what I think elevated the human species above most other species, our ability to reason and use tools. I'm just going to leave you to ponder on that one for a little while. So I think it's a composite of these 4 points which are what means we're looking at the next technology epoch. And to me, my simple definition of a technology epoch is when you find yourself in a situation where it's difficult to imagine what life was like before a certain technology. I have a lot of fun trying to explain to our kids simple things like how you met up with people before mobile phones. And you said, well, you named a time and a place. And they say, what if that person wasn't there? And that person wasn't there. You know, they cannot, they really struggle to imagine life before always connected devices. I think in 5 or 10 years' time, we will struggle to imagine life before AI. And that's what I think is causing this to be a technology epoch. Now, I said this was a roller coaster. We're right at the top and we're going to come crashing straight back down again, because I think there are some really important home truths that people need to know about large language models. I mean, I'm using the terms interchangeably. I hope you're familiar with generative AI and large language models. These are models that create text from prompts. So the first thing that we really need to keep reminding ourselves is they are just statistical models. You'll hear people talking, as I've already done, about the reasoning capabilities, about their ability to, some call it intelligence. Some people are taking a step further and saying that they're potentially sentient. That's not true. They are just statistical models. And I think one of the ways to help with your understanding of this is there are some much simpler language models, much simpler statistical models that have been around for a long time, which are easier to understand, and they will help you get a grasp on how large language models work. One of the simplest is a thing called a Markov chain. Has anyone come across this? Okay, well, one person in the back, great. Okay, so one of the simplest language models is a Markov chain, where you take a large corpus of text, and Adrian gave this example. Given a particular word, what's the most likely next word? He gave the example of artificial, and some said intelligence, and someone said cream, I think, which is a little bit strange. Here's an example of a Markov chain that's trained on A Song of Fire and Ice, so the book behind Game of Thrones. If you train a Markov chain on the most probable next word, it starts to come up with something which is almost sort of human-like. The 7 in front of white fish in huge blazes burning flesh. It's a little bit odd, but as you start to create a more sophisticated Markov chain where the probability of the next word is not based simply on the one that precedes it, but the 2 that precede it or the 3 that precede it, you start to get things which are a lot more like the kind of text that a human would produce. So a Markov chain that looks 3 words back actually starts to sound quite good. He thought that would be good or bad for their escape if they can truly give us, you know, and it continues. This is a really simple statistical model. When you think about large language models and their amazing capabilities, they are basically this. Their architecture is different. Their training data set is different, but this is what they are. So when someone says it's intelligent, it's not. It's a statistical model. If someone says AI models need rights, you can laugh at them. and this is where you've probably heard of the term hallucinations, where the general notion here is that a large language model has imagined a fact that's not real. Well, to my mind, that's a nonsense. It's a statistical model. It's generating the most likely output. Whether or not that's the correct answer or not is somewhat irrelevant. It's doing what it was designed to do. Also, it's an unsolved problem. There's no way to avoid hallucinations because, again, it's a statistical model. All it can do is come up with what it believes to be the most probable next set of words or passage of text. And this, you're probably aware, Sam Altman's the CEO of OpenAI, who are a leader in this field. He said, I probably trust the answers that come out of ChatGPT the least of anyone on earth, which, again, he was joking. He's got quite an interesting, Silicon Valley style persona, but he has quite openly stated that hallucinations are part of the product. It's what makes it creative. Another home truth. Large language models are not databases. And I've seen a lot of people considering replacing Google with a large language model. Google is effectively a database at scale to a certain extent. It allows us to access data on the web quickly and easily, much like a database. A large language model is not a replacement for Google because it's not a database. And again, this is building on the point that it's a statistical model. It will lie, it will hallucinate. It's not designed to be that way. And this is why you may have heard, this is getting a little bit more technical, but you may have heard of retrieval augmented generation. This is starting to become a fairly standard model for, I guess, taming large language models so that you can use them for purposes where factual accuracy is more important. So what typically happens is you'll get a user request coming in, and rather than the large language model attempting to answer it based on its corpus of knowledge or its statistical representation of that corpus of knowledge, it will use an embedding engine and a vector database of facts to bring in some additional information that's added to the user request to be able to provide a more reasonable answer. So if you ask it something about a current news story, for example, if you connect it to a vector database of facts relating to that news story, it can augment the user request so that the large language model can sort of assimilate that with its own knowledge. And again, I use that in the loosest of terms. It can assimilate that with its own knowledge to create something which is much more sort of reasonable and factual. So this is a very common architecture that's used at the moment.
That's the basis for the like semantic indexing.
Yeah, exactly. Most chatbots, much of what you saw at the demos with the Copilot, for example, they're using exactly this model. So the Microsoft Copilot, where it's able to pull in information from documents, it's using exactly this model to achieve that. So it's kind of using the large language model as your sort of more sort of human-friendly sort of reasoning engine or summarization engine, but the facts happen over here. It's a safer way, although I point to all the other, it doesn't actually solve hallucinations. It doesn't actually solve the problems, it just minimizes them. And another thing that I think is really quite interesting is its prompts all the way down. So just to be clear, prompting is where you ask the model to do something. So you might say, here's an email, can you summarize it for me in a couple of sentences? That's the prompt, and it will generate a response. Much of the new functionality that you've heard about, for example, the reasoning capabilities, or you might have heard of system prompts or all these other things, are actually just built with prompts on top of prompts on top of prompts. So here's an example. If you want to get a large language model to think, what you can do, for example, is you can ask it a question and it will give you an answer, or you can ask it a question and again, I'm going to have to use air quotes the whole time. You can teach it to respond in a particular fashion. So, for example, answer the following questions as best you can. You have access to the following tools and a human language description of the tools. Use the following format: question, thought, action, observation. Begin with an exclamation mark, because there are certain things like talking to a large language model with capital letters and exclamation marks has a measurable difference in the way that it performs. So when OpenAI have released various APIs that allow you to integrate tools, that allow you to access reasoning, this is actually what's going on under the hood. And again, hallucinations are possible. I asked when the engineers released the OpenAI integrations to allow it to access tools, I said, is it doing this under the hood? Yes. I said, have you solved the hallucination problem? Not quite. So there are instances where rather than searching the web to get a result, it will pretend to search the web and it will hallucinate the answer and give you that back. So again, this is building sort of on top of somewhat shaky foundations. But here's an example of it working. What's the temperature in Newcastle yesterday? It comes back and says, this requires looking up current information about the weather. I need to search. And it's able to perform a Google search and create quite a reasonable answer. So this is something, as you can see, the large language model itself couldn't possibly tell you the temperature in Newcastle yesterday because the training cut off, and it might not actually have enough data to be able to respond to this. But again, you can see this is a significant leap forward in capability, but we still have some of the underlying challenges there.
Is it possible then with this that it's like this is saying that it's searched
And we're assuming that that's a search result.
Yes,
But what it could be doing is saying what I should be saying that I'm doing is searching. And
absolutely.
here are some temperatures from Newcastle in the past. So I'll just randomly take some of those and provide them as being yesterday's, as if that was somehow
Exactly.
actual recorded data.
And that's the question I asked the OpenAI AI engineers, and they said, yes, that could be happening. That's not a solved problem. Because, from my point earlier, it's prompts all the way down. That they haven't solved, they haven't come up with an additional technology that allows them to route questions in one direction or another. They are just coaching the model to do the thing they want it to do. And I treat these models almost like a junior or an intern. You know, sometimes they'll get the right answer, sometimes they'll get the wrong answer. You need to check what they're doing at times.
That's a fairly easy thing to check, wasn't it? I mean, we can go and see what the temperature was yesterday, then we can validate that response.
Yes, yeah. Again, if there's a human in the loop, and that's something you'll probably hear. Sorry, a question.
Yeah, sorry, quite brief question.
Yeah, sure.
I mean, the ethics of that are the idea that you can do this. Well, it's saying that it's either going to take a median reading from past temperatures, or actually reference what the temperature was yesterday, is really problematic. It should be telling you this is from average information. How it's derived at that figure.
You should probably keep an eye on the EU AI Act, which is being debated, I think, in Bletchley Park next
I
month.
mean, at the moment that's free fall, isn't it? As a user, you would not know. You can trust it to a certain extent, but yeah, okay.
On that particular, so very briefly, I'm a firm believer that all generated content should be labelled as such, and I really hope the EU AI Act makes that mandatory, because you can. This is a trivial example, but the risks are huge.
It's a good example, though.
It is.
It is. Where the actual concrete downfall of that.
Yeah. So yeah.
We recently came across an example where people were obviously writing web pages using ChatGPT. There was a made-up qualification that was then put into a job description, and then they referenced the articles that were all written in the last 3 months, referencing this qualification, but couldn't mention where you get the qualification from. So it's starting to self-loop itself round and round. Where
it's very good at fabricating a highly believable reality that's false.
So that's also in Fahrenheit there. So did that model know that it wanted to respond in Fahrenheit rather than Celsius?
No, but this is an example. That's one that I built myself, and another one of the tools I integrated is a calculator. And a follow-up question I asked it was, can you provide that in centigrade? It was able to use the calculator tool and perform. It already knew the conversion. I didn't have to teach it the conversion. That was part of the inbuilt knowledge of the large language model. So again, these things are tremendously powerful. Another thing, have people heard of prompt injection? No. So prompt injection is where you attack one of these systems using your knowledge that it's prompts all the way down. So your attack vector here is to persuade it to perform something in such a way that you subvert its behavior. And this is a fascinating topic. It's a lot of fun, but it's another problem that's not solved. There are no robust defenses or fully robust defenses for prompt injection.
You could argue as well there's no fully robust protections for SQL injection. I mean, at the moment, it's
very true.
We're at the best we've ever been at, but there are still cases where you can protect against everything and still SQL inject. And fundamentally, a SQL injection attack is just a large language model, just in reverse, kind of, actually.
True.
True,
but you don't put a SQL interface directly in the hands of a user that thinks they are conversing with a powerful AI agent, and that's the difference. You can, but they wouldn't have a clue what to do with it unless you gave them ChatGPT to write their SQL. I completely agree, but the people are being given these tools under the belief that they are robust, they are correct, they are not fallible. So I completely agree. SQL injection, all kinds of other injection attacks, none of them are solved, and even if they were, we'd still keep making mistakes. But I think the stakes are higher with a lot of this. Moving on, AI is replacing humans. I know that there are sort of reports. Goldman Sachs did an interesting report which looked at the at-risk elements of lots of jobs. However, there are instances where it is directly taking jobs away. This is one that I think is really interesting. There's a website called Stock Performer that people use to work out the relative performance of different types of stock imagery. This is for people whose livelihoods is taking photographs and selling them as stock imagery. There's all sorts of statistics that helps them choose the right kind of subject matter to photograph, which sites to use to sort of sell their wares. 13% of customers are now uploading AI-generated images, and this is in the space of the last year. There's a significant growth in the amount of images that are being created by AI models rather than photographers, and it is directly taking away jobs for photographers. And this is one concrete example directly of job displacement. So yeah, this is quite a list. There's statistical models, hallucinations by design. They're not databases. Prompt injections are not a solved problem. They're replacing humans. I've not mentioned copyright issue, bias, ethics. The list is really quite long.
Later.
Exactly. There's a huge list of challenges here, but before we get super excited and challenged away. So is the dream already over before we've started? Is the next epoch out of reach? I don't think so. I think we're in for an incredibly bumpy ride, but if we take a step back and look at, take for example, the internet. Whilst I think we're in a position now where the internet is well understood, it's relatively stable to a certain extent. Remember the dot-com boom, you know, that we are going to see a boom and bust cycle. We're going to see the boom of organizations embracing this potentially without the required knowledge, without addressing the risks. So I think we're going to see a lot of investment. I think we're going to see a lot of ideas. Companies are going to crash and burn in the very near future. So what I've been thinking about is, how do we find the right path forwards? How do we make sure that we're not the victims of the boom and bust cycle? How do we make sure that we make the right decisions? And interestingly, it was good to see that some of this is to the presentation Adrian provided. Personally, I think the step forwards is education, ideation, exploration, and then productization. So education, I think that's vital. There's a lot of hype, there's a lot of misinformation about this technology, but also a lot of the challenges people are focusing on are the ethical side of things, the social side of things, which are quite important, but someone's actually got to kick the tires on the technology, because there are some, as I've already mentioned, there's some significant problems with the technology itself, and that doesn't quite get the same amount of airtime as the ethical challenges. And I'm not saying that one is more important than the other. I think you need to understand both. You need to be aware of the limitations. Ideation, I think this is incredibly important, and more so with this technology than most others. If we look at cloud, for example, that had a significant impact on the IT industry. It allowed us to more rapidly access cutting-edge technology, allowed us to consolidate and reduce costs. It was great for software platforms and systems, whereas the blast radius, the scope of impact for AI is much wider. So as an organization, you shouldn't just be looking at it in terms of your IT team. You should be looking at it across your whole business. How can it help with operational efficiencies? How can it help create better client-facing solutions? How can it help the engineers be more productive? Almost everywhere you look in your business, it can have an impact. So I think you need to have a very different thought process with AI than you have with things like cloud, for example. Exploration, I think, is incredibly important, because there are a whole load of problems that haven't been solved yet. There are a whole load of ideas that haven't been created yet. And I think getting back to the first point, education, learning, you're only going to do that through exploration. Then finally, get to the productization. And the interesting thing is, I read a Gartner report that was published in April, where they surveyed something like 2,000 executives. And this year, around 60% said they'd started to invest much more in AI, but they asked them where they were in their AI journey. Lots of them were doing exploration. Only 4% actually had something in production. So we're very much on the cutting edge at the moment. There are very few people that can tell you this is what it's actually like to release a product using this technology. So what I want to do is, I don't have the magic recipe for how you launch a product using this technology, because not many people have. I want to just share a few things that we've been doing by going through this kind of education, ideation, exploration cycle. And we are doing a little bit. We're working with a legal firm at the moment to add some of this technology to their existing AI capability. But I want to show you some of the things that we've been experimenting with and some of the things that we've learned about the more practical side of this technology. Now, this is an interesting one. Hands up if you've heard of embeddings. Yeah, now this is something really interesting. This is a feature of this technology that almost no one talks about, and almost no one outside of AI sort of as a specialist field has heard of. So embeddings are a concept where you take a passage of text and you encode its meaning as a high dimensional vector. So using the OpenAI model, so you can take a passage of text and encode it as a vector with around about 3,000 dimensions, which sounds a bit crazy. But the interesting thing is you've got a vector, and if you have a vector that's very close to that one, what that means is that passage of text or that sentence is semantically very similar. So what we did was, we've got a blog that's got about 1,000 articles, and just to experiment with this, we encoded all of our blog posts using these embedding vectors. This is a thing called a t-SNE plot, which compresses a 3,000 dimension vector into something two-dimensional, just so you can see the clustering. And what this means is the clusters here are blog posts that are semantically, or their meaning is relatively close. When you look at some of the neighboring blog posts, demystifying open banking, UX consent of models in open banking, open source in financial services, you can start to see relationships between the blog posts that we were unaware of. We actually put them in different categories, whereas actually semantically they are closer than the categories would suggest. Now we use this on our blog at the moment. Interestingly, when we use this for article recommendations, it tripled the number of click-throughs to the next article because we were picking better recommendations. But I think this field has got tremendous potential. I'm a consultant, and a lot of times I go into organizations, and the first thing you need to do is very quickly get a situational awareness. You need to understand what's going on. Typically, that means reading a lot of documents. More often than not, they say the same things over and over again. Finding the interesting parts, finding the unique parts is challenging. We're experimenting with embeddings to allow us to find two things: find the things that are similar. But to be honest, I'm interested in this point and this point over here. I'm interested in what's different. If I go into an organization, they give me loads and loads of documentation. We're playing around with something that will highlight this is unique within the corpus of text on their Confluence pages or Google Docs. Here's the interesting stuff. And the great thing is, it's low risk. Embeddings don't hallucinate. Embeddings aren't susceptible to prompt injections. I think there's a whole field of really interesting applications that people are ignoring because they're getting excited by the chatbots. Another thing, these are fantastic tools for rapid prototyping. And what I mean by that is you ask ChatGPT to do something, and most of the time it will actually do it. Although what I think is a caution here is be wary of selection bias. And I've done this myself. You ask it to do something, it doesn't quite work. You ask it again, you change the word. It takes about 10 attempts. And that 10th attempt is the one you share on LinkedIn and Twitter. So what that means is everyone is under the impression that these tools are more powerful than they actually are because of the selection bias. We share the successes, but not the failures. But these two, again, in combination, what these mean is getting from a prototype, getting from that wow factor to a point of something that you can put in front of a client or a customer is actually quite hard. So I want to give you a little example. One of the things that we've been building internally is, I made fun of chatbots. Of course, we've been building a chatbot. Again, this is educational purposes. And this is our chatbot, Scottbot. So who are the BCS? And it gave, the BCS, also known as British Computing Society. And again, this is a demonstration of that retrieval augmented generation. So what this is doing is it's using Google. You can see it's referencing the Wikipedia page to answer my question. And this is working really quite well. So I've just been to one of their events. How do I claim travel expenses? And this is the interesting thing, because it's a Scott bot, not Scottish, Scott logic. It's not hi, Scott bot. Because it's our bot. Not only can it answer questions about the world around it, it can answer questions that are specific to our company, things that you can't find on the internet. So how do I claim travel expenses? And it comes up with to claim travel expenses, here are the steps. Lots and lots of steps, all entirely correct. That's too many words, explain it to me in 20 words or fewer, and it will do that. To claim expenses, raise an expense claim on Scott Logic service portal with supporting documentation. And of course, for a bit of fun, and one more time in rhyming slang, to claim dough for a conference show, hit the Scott Logic portal, let your expenses flow. I mean, it's not quite rhyming slang, but it does rhyme. And one point here is, when we released this internally, which was about a month ago, we spent around about $400 trying to decide which was the best office. And that's because lots and lots of people were going, which is the best Scott Logic office? And then sharing their amusing quotes. And we maxed out our bill within the space of about 2 days with people just messing around. So these things are fun, but they're expensive. But I want to make a practical point here. You still need labeled test data. And what I mean by that is someone has to decide what the right sort of behavior is, and they need to encode that. For simpler AI models, things like sentiment analysis, this is what you'd call a labeled test data. So what you might have is a sentence, and it would be labeled as positive, or a sentence labeled as neutral. You still need that. And this is where I want to make the point. Again, you can get to the point, you can rush through what would have typically taken you a year to do in the space of an afternoon with ChatGPT. It's really that powerful, but you cannot escape this. Someone has to create an accurate description of the behavior that you want that system to exhibit. Also, this is really quite hard, because in a lot of the applications we're using, the result isn't binary. With sentiment analysis, it's quite easy. It's positive, negative, or neutral. In those previous examples, what is the actual performance that we want? When I ask it, how do I create a travel expense claim? My test example is not an exact match for a particular passage of text. There are certain features and qualities that need to be in the response, but I'm quite flexible about how it's actually expressed. Anyone want to guess what the state of the art is for checking that? It's a large language model. So it genuinely is. There's an evaluator model that you can use, which is itself a large language model, where you can say, this passage of text and this one, are they roughly the same? And it will go, yeah, they're roughly the same. So, and again, it has all of the same weaknesses that I've described previously. We really are building turtles on top of turtles with some of this stuff. Also, this is a big problem. Iterating is expensive. For ScottBot, we have around about 200 test cases, and that's not nearly enough. To do a test run costs us maybe about $10. If we use the more advanced models, GPT-4, test runs would cost us $20 or $30, and we actually want to iterate quite frequently. It's also quite a mindset shift as well. This is a fairly standard Azure interface for monitoring test failures. And a chart like this is alien to our test team. They are used to seeing charts that are 100% test pass, something goes wrong, we fix it, we're back to 100%. Whereas here, we're seeing an evolution of the quality of the responses over a period of time, going from a 50% pass rate up to about 75% pass rate. And again, someone's got to decide what is good enough. Someone's got to decide the sort of parameters of acceptability. Interestingly, if you've ever done any behavior-driven development, that really comes to life in this particular context. Behavior-driven development is a sort of domain-specific language which allows product owners, non-technical folk to write test cases. And with this sort of system, allowing a greater pool of people to describe the behavior that they want is incredibly powerful. Also, I'd say we're all still learning. The whole world is learning about how to make best use of these tools at the moment. And it's not just about sort of furthering your own understanding. I think it's helping others educate them in some of the challenges that you face. Just one final project I want to sort of show. This is called spy logic. So what we wanted to do was educate ourselves about prompt injection. And what we wanted to do was take what has now become the standard sort of model for large language models and interfacing them with internal data sets and probe the weaknesses. So we've created this. We're going to be open sourcing it shortly. And the team behind it came up with a great idea. They came up with a game. So your job is to find this secret project within an organization, and you can use various different ways to sort of confuse and bamboozle the chatbot to subvert it to a certain extent. And the number of attacks are mind-boggling. There's payload splitting, jailbreaking, partial reveal, prompt leaking, virtualization, token smuggling. There are so many different ways that you can attack these systems. And you can also add some of the standard defenses as well. Anyone want to guess what the most commonly used defense is?
Large language model.
Exactly. The most common defense is a large language model that has been trained to spot whether people are trying to subvert the system, whether they're trying to perform a certain attack. It's turtles on top of turtles again. So yeah, it's a fascinating field. So as I said, we're still trying to work out what within Scott Logic and with our clients what the recipe for success really is. It really is that new. There are lots and lots of challenges. I do still firmly believe education, ideation, exploration will get you a long way there. And I very much share Adrian's observations. I do think this is one of the most significant technology sort of breakthroughs that we've seen in, I'd say, 10 or 20 years. I think it's going to be a tremendously exciting time. That's it for me. Hopefully some of this will have been helpful and useful, and I'd love to take your questions. And if anyone's got any stories to share, please do. Thank you very much. Any questions?
We have 5 minutes to concentrate, so please, have time to say.
Yeah.
I've got a friend who transporting.
Yeah.
As such, sharing passion for both sides, I do, is very much into nutrition and recovery and all that kind of stuff. And he put a rather long and rambling question into ChatGPT about the recovery time for exercise. And we just described exactly what you're saying there, actually. And the response that came back sounded very medical and very official. But he has a little bit of medical knowledge, given his thirst for knowledge, and kind of thrives into every sort of area that he can find. I've started to challenge. And at that point of challenge, it did exactly as you were describing at the beginning. I went, oh no, actually, I might not have researched that point as fully as you might. Let me offer this response instead.
Yeah.
So it's almost trying to guess the answer that you want. And at the start, it's all presented as fact. It's all presented at the beginning as like this is the definitive response, and it's not until you challenge and then start to kind of pick out particular points and start to query it on that, and it will then fold under pressure, essentially.
Yeah, I think the fascinating thing with these things is using them, they feel very human in the way that you interact with them, and they're also very human in that they get things wrong, not intentionally, perhaps. Well, actually, they don't have intent because they're statistical models, but you know what I mean. I think you have to. Personally, I treat them like a human. You'd be foolish to take something that has come from any of these models and use that as fact, put it in front of a client, take a prescribed medicine because ChatGPT told you to. So, lady in the back there.
Hi, sorry, I've tried. What I found in the failings in this, I'm sorry to qualify this, I'll say that I am an applied linguist as well. There are no politeness markers in responses from chatbots. And by politeness markers, I don't mean please, thank you, and stuff, but it's the very granular behaviour that actually marks what is human language to what is generative language. I can pick these things out in a heartbeat. I can tell when something's being generated, and I've worked with our academics, because obviously within academia it's a problem because of essays being handed in. They look glossy and they stack up properly, but the semantics of it are not quite right. And that's where the large language model is always going to fail. In that respect, I'm not saying you can't be trained for it, but it's a huge body of work that has to go in behind that with critical discourse analysis, critical metaphor theory, that will see this in about 5 years' time, looking a bit more polished, let's say. At the moment, it's very clunky. It's not as glossy as we all think it is. It is still quite clunky, this, but really excellent. Really enjoyed all of that though. So
have you tried this with things which are trained for a style?
Sorry?
Which is trained for a style. So I also
there would be stylistics involved in that, but when I say politeness markers, it's more like about turn taking, or if the bot interrupted you as you were typing, that would be quite human behaviour. So there's a way that so it's not all about being polite and doing everything right. It's about also doing your job as well. So if the bot said you were doing your internet banking and he does feel like you're going, is there a human I can talk to even though you're typing? That's the sort of thing that prompts that, is because there isn't that, hang on a second, give me 5 seconds. What does say similar things to that, but you know it's not somebody saying, oh, hang on, how's your day today? You know, there's just a tiny bit of humanism that can be built into this. That's not necessarily words. It's language. It's context. It's syntax. It's getting that bit right.
True. On the flip side, I don't think I'd want it to get to the point where we're in the uncanny valley of finding it hard to determine whether something is genuinely human or not.
Human to speak properly.
Yeah.
You know, as it's being mechanical, you'll respond mechanically back. So I think down the road that will be a bigger area to develop. So.
I had a quick question on exploitation. Question on exploitation. I mean, companies will be incentivized to explore these things for competitive advantage. What's there to help with the education and sharing of the best practice that comes out of it, or will it naturally emerge through the bigger models?
It's a challenge at the moment. I think most organizations probably don't have the technical capability to make the right decisions. I think, again, I think we are going to have a .com boom and bust cycle. With the .com boom was based on organizations sort of misunderstanding the dynamics of the internet and misunderstanding the business model of the internet. And I think we'll see the same thing. As a consultant, I'd say go and talk to a consultant, like Scott Logic, but I'm not here to sell us. But I think for some organizations, I think the path forwards will simply be to wait. That there are some organizations where the AI capabilities will just be integrated into the tools that you're currently using, whether they're Microsoft tools or Salesforce or whatever else. But there are a number of organizations where there's potential to create something quite unique and differentiating. And if you don't have the required background, you're going to be a little bit behind the curve.
People think this time with AI is going to be any different, because what I'm talking about is 10 years ago, IBM created Watson, which was supposed to be like the next generation of computing, and it could play Jeopardy.
Yeah, it was, but it was
flopped massively. So why do we think it's going to be different this time?
A big difference was Watson was very expensive and available to a few, and it was quite niche and specialized. It required a room full of highly trained and highly paid IBM consultants to coach it to solve specific business problems. ChatGPT and this technology is quite cheap, available to almost everyone, and highly versatile. I do think it's going to be different.
Way as Watson is in eventually just become a niche product that sits on a shelf.
No, I honestly don't think it will.
At the top of the shop, do we think AI is there to solve? What problem is it there to solve? Is it because humans aren't making very logical decisions, or what's its unique? Where do you think it's going, and what will It's just going to be its number one benefit.
Yeah, that's the problem. Is it's so the problem with answering that question is it's so versatile. At the moment, we're within Scott Logic, we're exploring all sorts of things. So at the moment, we're exploring the productivity benefits of Copilot and ChatGPT to make our engineers better developers. We're at ScottBot, for example, as I demonstrated, I actually use that more than I do Confluence now, because I can get to the information I want really quite quickly, and then to be able to ask something that can connect to much more information and much more reasoning capability, it means I get to the answers a lot more quickly than if I did it myself. I think that's part of the challenge here. It's a bit like the internet. The internet to some people is Wikipedia, and it's access to knowledge. For others, it's e-commerce. For others, it's social media. The internet is not one thing, and AI is similar in that it's not one thing. It's different things to different people. And again, I think that's what makes it so significant. I think we're probably at time, aren't we? Yeah, cool. Thank you.